Hi, this is my continuation of testing the Honeywell sensor evaluation kit for Arduino, the SEK002, which this kind of shows it in the box. So that's the device that's on top of, I have a Cypress PSoC 6 BLE Pioneer Kit that's here. So the sensor kit is on top here. It's basically an Arduino shield, and it has different connections on it that you can put different sensors. So right now I have an ABP sensor from Honeywell on here, and that's connected with these hoses, and then I have a motor board over here with a small pump, a little mini pump, and a mini valve. And then the board also has a couple of TIP 120s. This is just to power those devices from the GPIO from the BLE, from the PSoC creator kit over here. This is so I don't blow out the GPIOs by powering those devices. And then I have over here, I just have a LiPo battery, and this is powering the board and those devices. Again, so I don't power off the board and cause problems with that. And then I have the cuff right here. This is basically a basic setup for, say, a blood pressure test. And that's kind of where I'm going with this. And then I do have another sensor, the other smaller, but this is a surface mount sensor that actually could be placed onto the kit over here, but it's too small for me to solder. I was able to solder some wires on it, so I'll see if that works. And then I have a humidifier sensor right here too, the humidity sensor. That'll be another one that I'll be testing. And so I'm using the ModusToolbox from Cypress as well to program this. This is it's already set up. It's been set, and I have a program that's running, and that'll run through the process of this. And it's basically waiting for input. That's why you see the blue LED that's blinking right now. But I can go through the toolbox right now, so I'll get rid of that. So inside here, so I have I used a basic kit that they had, or a project that they have, which was an I2C slave and master example that they have, and I use that as my starting point. And one cool thing with this is through the Modus Toolkit, or Toolbox, I keep calling it kit. So for here, so you have basically 5 different projects that are combined, each handling different aspects of the configuration. And with the way the toolbox is set inside of here, and this is an Eclipse, based on Eclipse IDE, and then they've added their features, but they've added this quick panel right here, and with that you can basically run this and then configure it and then build it and debug it all in one, and so that's kind of handy. And then when these were imported, they had a different name, and one thing that it does have, if you right click on this one right here, the main app, then you can go over here and you can rename it. So you can rename the application, and with that, so you can do this, and it'll go ahead and rename all this and everything below it and stuff like that. And that's actually pretty slick. That way you don't have to go and do that yourself. So that's pretty handy. And then the other thing that they have a middleware selector here too, so you can add other features to this. And so if we click on that, then we can see they have BLE, and they have different type of, you can have it for CM0 for that core, or for this core, and then you can have software or for hardware setup. And then they have a bunch of different configurations for that. They have a base one, and then they have all these other custom ones that are already configured, already code. So when you click on this, you add it, it adds the code and all the libraries required for that. You just have to create your own code to utilize those interfaces, but they provide the interfaces. There's a CapSense here. I've already added that manually. Probably could have done this a little easier through this, but I wasn't quite sure about this, and kind of learned after the fact. But that's okay. I learned how to add that stuff as well. And they have some crypto stuff in here as well that can be added. Some ADC, DFUs for firmware updates, and then emulated EEPROM. They have free RTOS, which is something I'm looking to add later. And this retarget IO, actually what they do, it translates printf, the standard I/O stuff, from C into a UART output, and I'll be using that for the debug. And then they have these other Seger graphic options that you can add. And these are based for the displays, and they have different, for touch or no touch. Also got the whether it's hardware or software, and so they have all these different things. And actually, for the graphic that I created for this, I used a Seger tool that they have to convert a bitmap into C code, and because that's what the example was using, and so I had to go find that and find the tool, how to do that, and it's actually pretty simple once it gets going. So I've done that already, and so there is that. And the way this is set up, this is basically the way the application was imported. You can do your own custom if you like to. And then so the first one is the config, and inside here they have a design modus. This is how you can design. You can set the pins, you can set up peripherals and things like that, similar to what you do in PSoC Creator. I'll go look at that later. And then inside here, this is where your main source file is. This is for the main app. So I've added the CapSense a header and some APIs inside there. And the I2C stuff is already there. I've modified it for my purposes. There's some interface stuff. Then there's our main, which is this over here. And then the standard I/O. This is part of what comes in with the retarget I/O. And then the UART stuff here for sending the debug output. So they have basically remapping printf, which they do with some macros and things like that. But that was part of the retarget I/O, which you can see gets part of the includes, I believe. Oops, where'd it go? Try to stretch this out. Yeah, so this is part of the includes that came in with the retarget I/O. So let's go through here again. And so I've got my main program, which I've added some structs here to handle. I'm using the RGB LED on here as well as the board LED, and then I have set up structs for the motor and the valve. So these are the port and the numbers. So these basically macros that come in. These defines come in from the configurator when you go do that. So those get set up, and I'll show you where that happens. And then I have my inits and then my code that I go through. So I'll go through basically a debug on this and see how it works. And so that's that piece of it. And then they have for the CM0 is the way they have it labeled. This is pretty similar to what you have in PSoC Creator, where it enables the core, and then it basically puts it to sleep, waiting for interrupt. That's pretty much that. Then over here you have a startup script that gets added, and this actually has to be edited. I don't know if they've updated the PDL yet, but for this version of the PSoC of the BLE board that I have, it actually, there was an issue because it's an older board, and then they had an issue with the way the things were set up, and they made some changes that accommodate for newer boards, but it wasn't in the PDL, so it actually didn't work with the newer PDL. But someone made a change, and I've added that. I don't know if they've actually added it to the PDL code online. I haven't checked it lately. And so that's the startup. Then you have the PDL stuff down here for your drivers. You have your includes, and then the source. So this is more than what I'm actually using, so it shouldn't be pulling it in if I'm not using it, supposedly. And then the other side of it here, and so there's more stuff. So these things are broken up pretty cool. This is basically the way that they break things out. You can do it your own way, but this is basically how a starter project will come in and will look like this. And so if we go back up here and get to the creator, so I double click that. You can actually do it another way. And once it kicks in, I don't want to kill it before it starts. There you go, kill it. So down here in the quick panel for the ModusToolbox, it should be, there's a configure device. It's basically the same thing, so that should launch this as well. So these is actually a separate application that's part of the whole ecosystem for the ModusToolbox, but they've also added links inside here, and it comes in, and you can launch it from there. There's a couple other ones, and I'll show you one other one, basically for the CapSense. So this is broken out into peripherals, pins, and platform. Then you have clocks, and then DMA. The peripherals are set up. You got analog, you have communication, which like a BLE, you have some serial communication blocks. So if you want to set up an I2C, these can actually, they have an easy I2C, the standard I2C, then have SPI, and then UART. So you can set these up for either one of those. This is a carryover from the example where there's a master and slave I2C. They are basically talking to each other. And then I've set up the kit UART. This is for the debug. And you see the baud rate set, and then the configuration for that, and then the pins that it's mapped to here, and for the transmit and receive. So that's port 5, pin 0. And then down here I have CapSense. I've enabled that. That wasn't part of the project, so I've added that. And so there's a whole bunch of good stuff inside here that has to be set up as well. And the CapSense is actually mapped to quite a few pins and ports. So there's port 7, different pins there, and then the 2 different buttons. And the way it kind of works, it's basically using button 0 transmit for both buttons. And so you've got 2 different pins from port 8 and then port 1. And it's just the way it's mapped out. And then the slider on port 8. And then you see here, so, and inside here also, so they have this CapSense configurator. So, and then a tuner. A tuner you can tune, fine tune it as well. But if you launch this one, you get this other tool that comes up. This is another separate tool. I think these are going to be launched from command line separately. And so we have our 2 buttons, which I had to add, and then set. The different sensing mode, multi-cap or self-cap, and then whether it's going to be a transmit and receive, or have transmit and receive. And then we got over here, so advanced have some general settings, and then the CSD settings for your clock, and then it shows your clock frequency, and you can set up some other stuff here, and then the CX for the other side of it, and then widget details. You can do some fine tuning for the buttons and for the different devices, and like for button 0 you can adjust the clock divider and the subdivisions and the finger threshold. So you can adjust this based on whether it's working or not. And then so these are 2 different buttons. Button 0, these are based on what's on the CapSense on the board, and then the slider, which has the different pinouts on it as well. These are all set for dedicated pins. And there's that. And then over here you see your pins are mapped out for the different signals, and then the pin mapping. I think that's it, right, for that. And then we'll close that one. It all went away and it comes back. It kind of scared me at first. And then it comes back. And the other thing you can do from here is, let's say from here, you have your pins that are mapped on this other side over here. You have this little link, and so if you click on that link, it'll take you over to the pins tab, and then you can see how the pins are mapped out. And it should take you straight to the pin, and then it'll also, supposedly when you do that, if it's not set right, it'll actually configure the pin's drive mode and everything else for what it needs for that particular connection. You also can see this is set for CapSense for the different MUX bus, and then it gives this outline or the back of the chip. I guess it's a ball grid array, right? So how it's mapped, I guess that's what it's showing. And just like what you would get like in PSoC Creator. And there's also analog diagram underneath here. You can see where the pins are mapped out, and then the flow going through here. You can see it's sense 0, and then how that's getting boxed up through that, and then how it's all mapped. So let me go bring that back down, and then we have the different pins for different features. We see here, so we get different. These are for the debug clocks. And then I have my valve out GPIO pin. This is set to valve, and then you have the master, the data, and then the clock for the I2C. And then we can see over here, you can see that it's connected to serial block 3 for the SDA, so that maps it out there. And if you click on this, it should take you back. It should take you back again. So it'll take you back over here to the peripheral clocks, and then we can go back and forth, right? So we go back over here. Well, that's kind of a nice little handy shortcut. And here's my kit UARTs for the debug. And this is for serial communication block 5. And then you got the transmit and receive. And then these are set. And then the green LED, RGB LED, red. And how they're mapped out for that. So that's the set. It should be a blue. Red, green. Ah, there's blue, way down here. Okay. Then you have your platform setting. This shows basically the flow for the signal, the logic that comes out. And then you can fine tune stuff with inside here. Then you have your clocks. So we have different clocks right here for the I2C, which is this one, it's not labeled. And then the CapSense. Then we have a bridge UART clock, and then I created this one just for the debug UART, so it didn't interfere with anything else. And also what you see down here is there's a code preview that shows you the interfaces that it will create for your particular device, and how it defines that particular device. I think on the ones that are not set, you can see it basically goes with the generic setting. But if you don't label it, it gives it something. And then there's DMA channels. I'm not using those on this particular example, but I think on the SPY, it was using this to basically stage data before it sent it out. So these can all be set for whatever you need to set it for. And so that's what this is. Okay, close that out. So we're back into the IDE. And let me go back down here. So yeah, you can go ahead and from the quick panel, you can clean, you can build the project, which should already be built. You can clean it. You can go to your project, build settings, and since this is Eclipse based, it's pretty much similar to what you would typically have for an Eclipse based environment. So you got your tool chain set up. You've got your paths and symbols that you can set up, your source locations, your includes, then your environment, and you got your settings over here, the target processor, you got your cross assembler stuff, you can set your settings here for your cross compiler as well as your linker. So all that can be done here. And then all the tool chains and the devices. So it's what you'd normally get out from an Eclipse IDE. Very similar. It's basically what it is, really. And they just added this ModusToolbox feature with all the other stuff. So it's like Eclipse with extra goodies. And so let me see here. So the device should be set up. Let me go back over to that window. Oops. Actually, let me go ahead and shrink this down a bit, so we can get the UART output. Yeah, we don't need a full one, I don't think. And then let me go back in here so we can look at the board. There's got to be a better way. So maybe what I can do, I don't think we need this full output. We can bring this down and bring this up. Kind of go like, we'll just do that. Uh-oh. I think that'll work. Okay, that might give us something. Yeah, we can kind of move this over here. It's not going to be that big. So, so if we want to go ahead and just run this, say like on a debug, so we go back to our quick panel, and then you have your different options for debug. And the other thing with this, when it was first set up, the board was set for KitProg 2, so that actually had to be set up and then upgraded for it actually to talk to it. And so let's go ahead and run the debug session. And again, it's the same as if you're used to Eclipse, it's basically the same as any Eclipse debug session. And so it has to load, erase. I guess it has to do that. Program it. You heard the valve go on and off. I don't know if you heard that. So that's setting up the GPIOs. So we got a breakpoint set so it stops, and then we can go ahead and we can walk through this. And so it set up some variables. I have a buffer that's set, and these are the signals that is being sent out. Got 2 ACKs and an ACK that are getting sent out, and then that's what initiates the communication with the sensor, since it's I2C. And then I get the data. So let's go and skip over that. So this is a generic init config all. That's and basically inits all the devices necessary for the board. Let's see if I hover on yeah, no, it doesn't show that. And then we'll skip over that. So you heard the valve click on again. So that's configured that. And then so this should set the red LED on. So I think we're looking at that. Yeah, so the red LED came on. And then go step again. And this is basically to init the I2C. It still has the master slave. I think the master is not necessary. The slave is not necessary. So this initialized the debug UART, enabled IRQs. This initialized the CapSense, which is CapSense is this piece here. There's 2 buttons and a slider. This will initialize the RGB LED, which is the other LED right here. And I'll go ahead and turn the motor off and the valve off. And print the heading. So that came through the debug. So there's a heading that's set up over here. Just something I did to kind of give an indication what's happening. And then it says press 0 to start, button 0. And then it should set the red LED off. And then it sets that. And then it's going to say waiting for user input. And so it's basically you're going to sit here in a loop. So I can go ahead and press start. And then the blue LED blinks, give an indication that it's waiting for user input. So if I hit button 0, then you hear the motor come on. This is actually, the cuff is actually pressurizing, so if I put my arm in it, it should inflate. You can barely see it, it's right here. And then you can see the valve. So I have it set once it gets to 1 that it'll stop and it'll try to normalize and then kick the valve on. So you can see the pressure increasing, and so that's being read through the sensor. And then it should go up to, it's getting tight. There it goes, stopped at 1. And then it tries to normalize it at 1. There's a leak in here, I don't know where it is. And then the valve turns on to release it. I probably should have another check in there to show the sensor actually releasing the air pressure and then sensing that too. So I'll probably add that later. And I'm looking to add maybe the RTOS and then the BLE and then add the actual e-ink display. But this is just to get the prove out my circuit, the pump, the valve, and then everything else, and then the pressure sensor that I can read that and get everything looked up. So it's a basic test that I've set up to check that sensor off this board. And then using ModusToolbox, so that was the other part of it. I was using PSoC Creator before, so I wanted to try something new with the ModusToolbox and then see if I can accomplish this using that. And so far, it's been a learning process, but it's actually working out nicely. So that's pretty much it for that. So it cycled through, it's waiting again. You know, if I press it, then it should do it again, right? Yeah. Should do the same thing. And actually, the way I have it set, I can push button 1, will stop it. And then it goes back into where it's trying to normalize it up to 1, but that should stop after 10 tries and then release it. So it was like a safety valve for me, so if something went haywire and the pump was going, then it just didn't continue to go. So that was that's that. And so that's what I have so far, and I think I have one more. I want to set for the BLE, do some other stuff, and then get this basically so a mobile device can read that. And then I have the other sensors, the smaller sensor, which should connect over here somewhere. There's no way for me to solder that on the board. And then the humidifier, humidity sensor. And luckily this one is set for a different I2C address. Actually, I think these two sensors, the two pressure sensors, are the same, so I can't test them both at the same time. And so there you have it. And so next time, maybe the BLE stuff.